Let's take a look at a dimensional analysis problem that might be a little bit more difficult than the ones we've done in the past. The problem reads this. A boat accidentally spills 8 barrels of oil into the ocean. Each barrel contains 39 gallons. If the oil film on the ocean is 310 nanometers thick, how many square meters will the oil film cover? This is a very simple, straightforward problem. However, what makes it difficult is not being able to understand a fundamental idea of what's going on here. So before we actually cover this specific problem, let's take a look at a simple example I want you to see. Suppose I have a rectangular prism. So let me draw this here. Alright, so there's my rectangular prism. And let's say that the length is 6 meters, the width is 3 meters, and then the height is 2 meters. This is obviously not drawn to scale. Alright, if I asked you to find the volume of this rectangular prism, you'd probably be able to figure that out fairly simply. Base times width times height. So 6 meters times 3 meters times 2 meters. And that would give us 36 meters cubed. Alright, so this is the volume of the rectangular prism. Now, suppose I wanted to know what is just the surface area of this particular rectangular prism. In other words, I just want to know the top part right here. How would you be able to figure that out? Well, all we'd have to do is divide out the height. So if this is the volume, I would just divide by the height, which is 2 meters. 36 divided by 2 would end up giving me 18. And the meter would cancel out one of the meters up here, leaving it with meters squared. So this would be the surface area of the rectangular prism that's at the very top. Seems pretty straightforward. However, when we're dealing with a problem such as the one we're given, it might be a little bit more difficult to imagine. So now that we have that understanding of what's going on, let's try to go back to the original problem to see if we can figure this out. Alright, so you have the ocean, and you have the spill of the oil on top of the ocean. Even though it's really hard to imagine, that spill is actually a three-dimensional object. It spreads out over a certain width, it spreads out over a certain length, but then also it spreads out over a certain height. That height that spreads out, although it's very, very small, is what they mean when they say that it has a thickness of 310 nanometers. We'll get to that part later when we get to that part of the problem. For now, let's start with what we're given. We're given 8 barrels, so we know exactly 8 barrels have spilled into the ocean. Alright, what can we figure out from this 8 barrels? Well, we know that every 1 barrel contains 39 gallons of oil. So the barrels cancels out, and now I know how many gallons is in the ocean. Now the unit of gallon is actually a volume. But as you can probably guess, we don't ever deal with gallons when we're dealing with chemistry. And so we need to find some way to convert gallons, which is a unit of volume, into a unit that we often deal with when we're dealing with chemistry. And that unit might be liters, centimeters cubed, or meters cubed. So let's go ahead and calculate gallons into something that is actually part of the metric system. When I look up gallons on the internet and want to convert that into something of a metric system, I end up finding out that 1 gallon is equal to 3.785 liters. Now that gets us out of gallons and into liters, which is something we're more familiar with in chemistry. Alright, I somehow need to get to this idea of squared meters. And so I'm going to get out of liters, and I'm going to end up transferring that into milliliters. The reason why I want to do this is because I want to get from milliliters now to centimeters cubed. Giving myself a little bit more space, I can do that now. So right now the liters cancels out, I'm in milliliters, and so I'm going to end up going 1 milliliter is equal to 1 centimeter cubed. The milliliters cancels out, and now that I'm in centimeters cubed, I can get from centimeters cubed into meters cubed. The meter cubed is 1 since it's larger, and the centimeter cubed is going to be smaller. It's 1 times 10 to the 6th centimeters cubed. or in other words, 1,000,000 centimeters cubed in 1 meter cubed. Now, to some of you, this step right here, or I should say this series of steps, might have seemed a little too much. Maybe you're thinking in your head, couldn't it have been done a different way? Couldn't I have used different conversions? And the answer is, of course you could. There's so many different ways you could have converted. The reason I chose to do it this way is because a lot of students are used to these conversions. So while it may have been a lot of steps, at least you could understand the concept along the way. So doing that, the centimeter cube will cancel out, and now I'm left in meters cubed. Let's go ahead and stop and calculate what this would be. All right, when I calculate my answer, I end up getting 1.18092 meters cubed. Now I'm not rounding yet to sig figs because this isn't my final answer. Remember when we talked about the cube and the volume? Well, this is the volume of this cube, or I shouldn't say cube, but this rectangular prism of oil. We don't want to know what's the volume of the oil, we just want to know what's the surface area, or in other words, what's the square meters of oil. We already know what the height is, which is in nanometers. So, to get my surface area calculated, all I have to do is take my volume divided by what that height would be, and that would give me my surface area, which is the answer. I just calculated what the volume is of this particular oil spill. It's 1.18092 meters cubed. I'm going to divide that by the height of the oil spill. Even though it's really tiny, there still is a height, or thickness I should say, to that oil spill. It's 310 nanometers. Before I can put that down in the denominator, we have to make sure that that's also in meters. So 310 nanometers is the same thing as saying 300 times 10 to the negative 9th meters. Another way of saying that is 3.10 times 10 to the negative 7th meters. Both are the same answer. It just depends on how you want to write it. So when we calculate through, this meter will go away. Out of the meters cubed, we'll be left with meters squared. And our number is going to tell us what that thickness, or excuse me, that area is of the oil spill. Now, before I write my answer that I calculated, let's go back and look at what our significant figures are. Well, I have 2 significant figures here, 2 significant figures here, 4 significant figures here. All of these numbers were exact numbers, and so it looks like my lowest significant figures is 2. So my answer in 2 significant figures would end up being 3.8 times 10 to the 6th power meters squared.